Okay, so now we want to focus on how you draw the ray diagrams. We'll look at 3 general cases to construct these ray diagrams. So for the first case, an object in optically more dense medium and the observer in optically less dense medium, like the goggles case. 2, the object in optically less dense medium and the observer in optically more dense medium. Say for example, you're in the swimming pool looking out at something in the air. Okay, and 3, object is partially immersed in optically more dense medium. For example, the rod that is partially immersed in water. Okay, case 1 is when we have an object in the optically denser medium, like the goggles in the swimming pool, and the observer is in an optically less dense medium, so like the light is traveling into the air. Okay, so first you need to locate the position of the image, which will be vertically above the object. So you can use the calculation n equals to real depth over apparent depth, okay, to calculate the position. Say for example, if n is 1.5, the real depth is 3 meters, then you can calculate that the apparent depth is 2 meters. So you locate the position of your image here. That's vertically above the object. Okay. Then step number 2, draw 2 rays from the image to the eye. So from the image here, we're going to draw 2 rays to the corner of the eyes. Okay. So make sure it's dotted line from the image and solid line to enter the eye. Then another light ray. Okay, dotted line here and into the eye. Okay, then number 3, you have to draw 2 rays from the object towards the point of incidence. So this is the object to the point of incidence. Oops. So you draw the 2 light rays. Okay, draw the arrows. These are the incident rays. And check we have undergone refraction correctly. So when moving from water to air, optically more dense to less dense medium, the light ray have to bend away from the normal. So it is correct in this case. Case number 2 is when the object is in a optically less dense medium. Say for example, you have a tree there, okay, and your observer is in the optically denser medium. So you are swimming in the water and then you're trying to look at the tree above the water surface. Okay, so first of all, you need to locate the position of the image. But this time, the position of the image will be vertically above the object. So it looks like the object is further away from you or the observer. Okay, then draw 2 rays from the image to the eye. So from this image above, draw the 2 rays to the eye. Okay, and then 2 rays from the object towards the point of incidence. So this is the object. You're going to draw to the point of incidence here. Okay, and the arrow should go towards the eye. Okay, so again we check the refracted rays. Now you're entering from a less dense medium, your air, into the denser medium, water. The refracted ray should bend towards the normal. Then you have the correct diagram. Okay, case number 3 is when the object is partially immersed in an optically more dense medium, like your rod or your pencil partially immersed in water. Okay, so to do this, we're going to choose a point on the object and construct the ray diagram using this point only. So let's say I'm using this point. So my image will appear higher than the actual position of the object. Then you need to draw two rays from the image position to the eye. Two rays from image position to the eye, and then the rays from the object to the point of incidence. And you saw that the light ray bends away from the normal as it enters the air. Okay, so we have one of this position. Then you're going to draw the other position. Okay, let's say it will be above also, and we will have to join this to the edge. Okay, complete the diagram to join the rod at the interface. So you see the rod appears to be bent in this way. Okay, so you connect the image of the point to the object at the boundary between the two media or the interface. Right, we've come to the last part of the chapter where we are going to look at the key ideas that have been covered so far. Number one, refraction is the bending of light as it travels from one optical medium to another of a different optical density. 2. Refraction occurs because the speed of light changes when traveling through different optical media. And number 3, the first law of refraction states that the incident ray, refracted ray, and the normal at the point of incidence all lie in the same plane. So we are not learning the second law of refraction at the moment yet. Point 4, light is both reflected and refracted at the boundary of two optical media, and we say that more light is refracted than reflected. Okay, and one of the application is your one-way mirrors. Okay, 5, objects in water appear closer to the surface than they really are due to the refraction of light. That is where you see the apparent depth, and you have the misperception of the depth where you see that the water is shallower than it really is. Okay, and number 6, the refractive index n of a medium is defined as the ratio of the speed of light in vacuum to the speed of light in medium. That is the n equals to c over v. Then you can also use n equals to the real depth over apparent depth if your light ray is traveling from the optically less dense medium to the optically more dense medium. Okay, so that's the end. Then attempt your test yourself, 12.2 question 2, 3 and 4 in the questions before you check your answers.